Welcome to Python and Data Analytics Internship Program of October 2025. Today we are going to cover exception handling in Python. So let's see why we need to learn exception handling. Basically, if you have think about it, like in your life or in every subject, there are some exceptions which you have to deal with them. Okay, like in chemistry there are some elements that are different from other elements, that or they show a behavior that is generally different from other elements, so they are exception, and we need to know how to handle those exceptions. Similarly, in physics, in maths, everywhere there are some kind of exceptions in your life also. Like this also, we also have exceptions in Python. Okay, when you code, there are some exceptions that you need to handle so that your code doesn't crash. Okay, if your Python, like in the beginning of this internship program, I told you that Python is an interpreted language, right? It interprets line by line the user written high level language to machine language, and then it find out there whether the code written is correct or not. Okay, if it is not correct, and any error is present in it, then it will throw an error. So what happens is that suppose we have a line of 100 codes and error occurs at line 3. So all the lines below that line 3 will not get executed till you resolve the error at line 3. Okay, so what is happening here is our program is getting crashed. It is not executing completely, it is getting crashed at line 3. So we need to use exceptions there. Like if I am finding that error, I need to tell Python, okay, Python, for now, you display the message to the user and ignore this error, and then continue to execute all the lines below that line 3 in which the error has occurred. So that's why we need exception handling to maintain code reliability, to maintain the effectiveness of our program, and a error in one part of the program should not affect the whole program. That's why we need exception handling. So let's see. Errors are normal part of coding. Okay. If you are getting errors in your program, that means something is working. You don't need to worry about it. So it's a very normal and common thing while writing codes. Every developer, no, it doesn't matter how experienced he or she may be, errors are normal, and if they occurs, then it means that something is working and something is failing. Okay, so treat errors as a step towards a successful program. Errors are a normal part of coding. Okay, they occur very frequently. Without handling them, program crashes abruptly. It means if we don't handle the error, like I told you earlier, if a error is occurring in line 3, then all the lines below that line 3 will not get executed and our program will get crashed. Suppose what if we are working on a huge application, like take an example of Flipkart. Flipkart has different functionalities. Suppose an error occurs in one of the code specifying one functionality of Flipkart, like add to cart. So if some error is occurring while adding an element to the cart, the whole Flipkart should not get shut down. Okay, the whole Flipkart code, that is the main production code, should not get crashed. That's why we need exceptional handling. Like if an error is occurring in add to cart function of a Flipkart, then it should indicate the user that there is an error and you need to resolve it. Other parts of the program should keep working as it is. They should not get halted because of their error. That's why without handling them, program crashes abruptly, and we need to tackle with this situation. That's why we need exception handling. Exception handling helps detect runtime errors, maintain program stability, provide user-friendly messages. Okay, like what are the errors that are occurring during runtime? Maintain program stability, as I have given you the Flipkart example. It comes here very perfectly. Provide user-friendly messages. This we will be seeing in the code in the next slides. Okay. So what is an exception? An exception is an event that occurs during program execution that disrupts the normal flow. So like Python is interpreting line by line all the lines of the program. Now an error occurs. Okay. So what is happening is that there the normal flow of the program is getting disrupted. So we here we will be using an exception. It will be used as an event during program execution. Okay, that disrupts the normal flow of the program. Basically, it will tackle the line 3, ignore the line 3, disrupt the normal flow, and again continue to execute all other functionalities of that program and display the message to the user. Okay, so an exception is an event that occurs during program execution that disrupts the normal flow. Common examples of exceptions in Python are zero division error, value error, file not found error, and index error. So let's see. There can be many more errors. These are the 4 errors that I'm going to explain to you. Okay. So zero division error basically means when you try to divide a number by 0. In maths, you have also seen that when we try to divide a number by 0, it will give an infinite value. It will not get divided basically. Okay. So that error occurs in Python also. I told you earlier that Python is nothing just a logic, just a math and English applied together, and that is getting translated. The logic is getting translated into machine language, and then the machine is executing that program on your behalf. So likewise only thus like in maths we have a zero division error. In Python we are also having it. Suppose we try to divide a number by 0, then it gives zero division error. What is value error? When you pass invalid input, like you have defined that you will be taking int and you are passing a string in that, then it will give you a value error. Okay, when you pass an invalid input, basically if you want to take int and you are passing a string, then that is an invalid input and it will throw an value error. We will see it in the later slides in the code. File not found error, trying to open a file that doesn't exist. Okay, this error mainly exists when uh, you will be dealing with file handling. Okay, when you deal with file handling now, and if you try to read a file that is not present in your project folder in the path that is you specified, then it will throw an error saying that file is not at that particular location. You may be trying to access a file that doesn't even exist. So file now not found error occurs when you try to open a file that doesn't exist. If it exists, this error will not come. If the file doesn't exist, then it will throw an error indicating the user that that particular file is not present in the project directory. Index error. When you access an index out of range, basically like you have learned about list now. So suppose the length of our list is 5. It will be indexed from 0 to 4. And if you try to index if you try to access an index like 7, 8, 9, 10, that is not even in the scope of that list, then it will give an out of scope, basically index error. It will go out of scope. You are trying to access that index that is even not present in the list. Okay, here you are doing something imaginary, that something is not present and you are trying to fetch that. So it will throw an error saying that this particular index is not available. So it will throw an index error. Think of it as an unexpected behavior your program must be ready for. So what this line indicates is that exception in Python, you should treat exception as unexpected behavior your program must be ready for. Suppose your program is going to throw an unexpected behavior that you are not ready for, but your program should be ready for it by handling it using exception handling. The try and accept block. So here you are going to learn about the basics of exception handling. like with if else comes, if else are inseparable together. Similarly, try and accept. Okay, this is the basic syntax here. Like try, the code that might cause an error. Here you have to write all your logic that you want to apply, and in accept block you will define that if this error occurs, what steps it needs to take. Okay, if an error occurs in try block, then accept block will get executed. If no error occurs in try block, then this accept block will not get executed. If try block is finding or throwing any error, then this accept block will be ready to tackle with any kind of error that this try block is throwing. Okay, let's see in this example. Try. Here we are taking an int input, enter a number, and print 10 divided by x. Here we are telling that except print something went wrong. Okay, let's see with an example in the code editor. Okay. So suppose we are having a try block. As I told you that everything should be written in try block. Wait a second. Okay. So in try block, we should write our logic like I am taking an input which is going to be converted into it. We are doing typecasting here. We are going to use input function which will take an input from the user, that is a number, enter a number. Okay, now we are performing some operations on it and trying to print the result like 10 divided by x. Now we have to write the accept block. If we find any error in the above code, then we should throw some message that user can interpret. Okay, something went wrong. So let's try and run this. Now it is asking for us to enter a number. We are entering 2 here and you are getting an output 5. What if I sorry, what if I pass 0 as an input? We are intentionally we intentionally want to throw an error, that is 0 division error, to show you that how this except block is going to handle all these errors. Now I am trying to enter 0 here. Now it is saying something went wrong. What it means is basically that when we try to divide 10 by 0, then it throws 0 division error, which is telling us that something went wrong. Except block is now being executed. And try block fails, except block get executed. Remember this. Okay. So now let's move with the next thing. Handling specific exceptions. Now you want to in the earlier example, we are generalizing the error. We are not handling a particular error. Like we know that we are getting 0 division error, but we are generalizing it that something went wrong. And it is not very informative for the user also. Hai na? So why use specific exceptions? Basically, we want to use specific exceptions so that they can be more informative to the user and we can handle that particular error with a particular set of lines or with a particular set of code that the user has defined, or it can give a user an indication that this particular error is getting is occurring. You need to resolve this, and user is very easily able to debug that code. Okay, so that's why we need to use specific exceptions. Caching specific errors help you know exactly what went wrong and handle each case differently. This is what exactly I was telling you, that it tells the user that where the problem is occurring. Like you went to a doctor and doctor asked you that what are the symptoms that you are feeling, etc. Okay, if you only went to the doctor and tell him that you are feeling unwell, so you are generalizing your disease. You are not, the doctor will not be able to pinpoint the exact cause that you are feeling unhealthy right now. If you tell something more information, or if you give him some more information that you are having a high fever, you are having coughing from 10 to 5 days, or etc, etc. Okay, if you tell doctor more information about the symptoms, then the doctor is pinpoint to locate the type of disease that is occurring, and he is able to provide a proper remedy or solution for it. Similarly, if we throw in very informative error to the user, if we throw in very informative message to the user, then the user is very able efficiently able to handle and debug that error that is causing this thing to break. Okay, so user is able to very easily debug that code, and the code is becomes very reliable and very adaptable. Okay, so that's why we need to use specific exceptions to know what went wrong and handle each case differently. What are its benefit? As I told you, makes debugging easier and improves code readability. What is debugging? Basically removing the errors and making the code correct. We are pinpointing what went wrong and then handling it so that it can work again. So makes debugging easier and improves code readability. Real life analogy, different problems need different solutions. You wouldn't fix a car tire and a broken engine the same way. Okay, so it's a very good example. You can correlate with it. Like you are going on a trip and suddenly your car gets punctured. Okay, and you called a mechanic and told him that your car is not working. The mechanic will come and then find out that, oh sir, please, your tire has got punctured, you only need to use the Stephanie and then change the tire. And if now consider scenario 2, you called the mechanic and you told that the car gets punctured, the mechanic will tell you on the call itself that, sir, please use the Stephanie to change the tire, it will get resolved and you will be able to go on your way. Okay, so different problems need different solutions. If you are specific about a particular problem, a particular solution will be going to solve that particular problem. If another problem occurs, then you need to use a same solution or maybe a different solution. It might happen that sometimes same solution works for two scenarios, but every problem is going to get resolved by uh, implementing another solution. Okay, different problem requires different solutions. Similarly here also, different error requires different solution. That zero division error, in order to solve zero division error, you need to ensure that your input should not get divided by 0. In order to solve value error, you must ensure that the input you are getting from the user should be of int type, not of string type, if you are considering an variable with type int. That's why every problem has its own solution, every error has its own solution. That's why we need to use specific exception handling. Okay, before that I should show you some code so that you are able to correlate it with very easily. Now here we were generalizing the error. Now here we are telling that zero division error. If zero division error occurs, we want to tell the user the denominator should be greater than 0. Okay. Now let's try it again. When we try to enter 0, it is giving us the denominator should be greater than 0. Now you can use as many except block as you want. Only one try block and as many as except block you want. Now we want to deal with value error. What if we are not getting an zero division error and we are getting an value error? We need to handle that case scenario also. The value of input is invalid. Okay. Now let's try it again. And I am inputting an string. Instead of number, I am inputting Rajat. So let's see what is happening. Now you are able to see that the value of input is invalid. This block is not getting executed because we didn't, because at this line, our program failed at this line only. X equal to int input, enter a number. When you try to enter a string, this throws an error. This goes to the except block. Except block sees that whether the error is zero division error or value error. The current error is value error. That's why we are printing the value of input is invalid. Okay, we are getting this as an in the output. So here we are handling different types of error. Now in exception handling, it there are few terms that you should also remember, like else and finally block. Till now we have understood about try block and except block. Now we want to know about else block and finally block. Else block executes only when no exception occurs. When the try block get fully executed, only then the else block will get executed. If any error occurs in the try block, else block will not get executed. Instead, except block will get executed. Okay, remember it. If try block is getting completely executed, then else block will also get executed. If try block fails, then except block will get executed and try else block will not get executed. Finally executes every time, irrespective of the fact that whether the try block is throwing an error or not throwing an error. This block will get executed every time. Now you might be wondering, sir, that what is the use of finally then? If it is getting executed every time, even if the error occurs, even if no error doesn't occurs, so why we are using finally? Basically finally is used to write a code that is need to be executed compulsorily in your program. Suppose you are having a database connection and its logic is written in this try block. If due to some issues your database connection throws an error, then you are going to handle it through exception handling. Now even if it throws an error, at the end you need to close your database connection until the issue is get resolved. Even if try block is not throwing an error and everything is working fine, at the end when the uh, work of database connection is done, like the data you want to fetch, you get it. At the end, you want to close that database connection every time. So even if error occurs, even if error doesn't occur, you need to make sure that your database connection should get closed at the end of your program. That's why we need finally there. It defines the logic for that code that is needed to be executed every time, doesn't matter what is happening in the program. Okay, that's why we use finally. So let's see with an example. Like this was our example earlier. In it only we will use else print executing else block, and then we are going to use finally, then print program execution is completed. So let's try and test it. Now we are not going to throw an error intentionally by putting invalid value or uh, zero division error. Okay, I am putting the value as 2, and let's see, we are getting 5. As in the try block, we are going to print the result of 10 divided by the input which we have taken from the user. We are getting 5. Now as you can see, else block is getting executed. You are getting the print message from here. Now after that, you can see that finally block is also getting executed. Program execution is complete. Now let's try it again by intentionally throwing an error by inputting 0. Now as you can see, the except block for zero division error is getting executed. The denominator should be greater than 0. And finally block is getting executed. Program execution is completed. So what it indicates is that try block will get executed every time. Sorry, try whenever an error occurs or doesn't occur in the try block, finally block is getting executed every time. If no error occur in try block, then else block is getting executed after it. If error occurs in try block, then except block will get executed to handle that particular error, and after that finally block will get executed. Students, there is something I also want to add on to it. Like, what is this zero division error? What is this value error? Basically, they are the subclass of this class, except exception. Print something went wrong. Okay. So this is the parent class, exception class. In this, all these value error, zero division error, index error, these errors are subclass of this parent class. Basically, these errors are a part of this exception class. So at the end of the except block, you can also use exception to handle those errors that you have not specifically defined here in the except block. Okay. So in order to deal with those errors, you can simply use the representative of exception. So you might be thinking that why to use then these classes, why not use exception class only? Because specifying that particular error, the user is able to know that denominator then 0, so the user will not input 0 as the 0 as input, and you will not be crashed. It in the generalized way. Everything is generalized if you are using exception. Every subclass, it knows every subclass generalized error. Suppose I am doing really well. Okay. And a string as an input. Now you are able to see that something went wrong is getting printed. Because it is not a zero division error, it is a value error, and have not specified particular types of error. Then if the user has not specified particular error, then it will handle those errors in a generalized way, so that none of the error should be getting missed. And remember that except exception block or as the last except block if you are using multiple except block. Why? Let's see. If you try to print this above na, like this. What happens is that I am trying to enter a value 0. So according to you, our output should be 0 division error. But as I told you earlier, that Python is an interpreted language. It gets interpreted line by line. Okay. So first this line will be getting interpreted, then this line will be getting interpreted, then this and then this. As soon as any error occurs, no matter which error is it is the parent class. It will be able to handle that error. So when you throw in 0 division error, now this except block will get executed. As soon as it executed, it rejects all the below except blocks and moves to the finally block. Let's see with an example. I am going to throw in 0 division error by entering 0. Let's see the output. Something went wrong. The denominator should be greater than 0 is not coming. This except block is getting executed. This particular block catches the error and then displays a message that is written in it. This block will never get executed. That's why this exception block will be always the last block of your except block if you are using multiple except blocks. Now, if we try to run it and enter 0, you are able to see that the denominator should be greater than 0 is coming. Okay. Now let's move to the. Now there are some more things like raise statement, although it is not used very commonly. Used to manually raise an exception when a specific condition is not met. Basically, when you try to define forms, okay, in it we use this raise statement for validating user inputs, preventing invalid data from entering your program, like the length of the phone number the user is entering should be strictly 10, not less, not more. So to raise an exception there, if you are inputting less values or more values in your phone number, this raise statement is used. Enforcing rules, no negative age, like age can never be negative, okay, and then can never be 0. So to basically tackle with these cases in the form, like Google form, etc., the raise statement is used, like no empty passwords. Okay. So let's see this real world example, student marks program. Here, what is happening is that you there are marks 85, 90, and 78. Okay, and in we are taking the index from the user. We are indicating to enter the index 0 to 2 to view the marks, because we know the length of our list is 3 and index will be from 0, 1, and 2. Then print marks of index. That particular marks will get printed. Now we are using explode to handle that in case the user has inputted wrong value, like value error. Please validate it. If the user enters a string, so this line will get an error and this except block error, and after that, this finally block will get executed. If a user tried to enter an index that is not in the range 0, suppose the user tried to enter 3, then this particular except block is getting executed because it is an index error. Print error, index out of range, choose between 0 and 2. Okay. Likewise, if this try block doesn't throws an error, okay, all our things are perfect, all the things are perfect, and this try block is getting executed without throwing an error, then this except block will not get executed, this will not get executed, else block will get executed, successfully retrieved marks, and finally block will get executed. Execution completed. Okay. So what are the key takeaways from today's session? Try except prevents program crashes, as we know it, as we have seen through the code, also through the examples, live examples, that our program is not getting crashed. But what we mean by crashing is basically this. If I am not using this book, na, and not the block, what will happen is now I try to run the program and I am intentionally throwing a zero division error by inputting 0. Okay. Now here our program is getting crashed. Earlier, when we are using try block, we are not getting this message. So we are handling that particular error and preventing our program from crash. Else executes only when no error occurs, as I told you. Finally execute always. Raise allows you to trigger custom exceptions like in forms. Help you write robust and reliable programs. Exception handling helps you write robust and reliable programs. Good handle it and use meaningful error messages for you so that it is very easy to. Now we assignment which you have to do. Create a calculator program that accepts two numbers and an operator plus minus multiply and divide. Any one of them can be your user input. You try accept else final block should handle invalid input, basically error, division by zero, zero division error, and invalid operators. Okay, you have to calculate using try except and finally block, and you have to upload that assignment on this Google form. For support and help, you can contact us here. Thank you for joining today's session.